There is a question I've been sitting with for a long time, and I want to put it to you directly. When you can't explain something, is that a problem with you or with the thing itself? For most of human history, we assumed the former. The universe is explainable. We told ourselves, we just need more time, more tools, more intelligence. The darkness is temporary. The light is always coming. This is, at its core, the entire promise of science that reality is legible, that patient inquiry will eventually read it out to us in terms we can grasp. I still believe that, mostly, but I am becoming less certain that it applies to what we are building, because there are now two different kinds of incomprehension in the world, and almost nobody is talking about the difference between them. The first kind is the kind we know, the kind we have always had. It is the incomprehension of complexity, the feeling you get when you look at a weather system, or a financial market, or the firing patterns of 100 billion neurons, and think this is too much to track, too many variables, too many interactions. I cannot hold it all in my head at once. This kind of incomprehension is frustrating, but it is, in principle, fixable. You build better tools, you decompose the problem, you use computers to track what brains cannot. The darkness of complexity is not fundamental darkness. It is a practical obstacle. We navigate it every day. The second kind is different. The second kind is the incomprehension of physics, and that is what quantum AI introduces. Not a bigger version of the first problem, a different category of problem altogether. A problem that does not improve with more time or more tools or more intelligence, because it is not rooted in a limitation of the observer. It is rooted in the structure of reality itself. I want to explain exactly what that means, and to do that, we need to start at the beginning. With the first black box, ask the engineers at any major AI company a simple question. Why did the model give that answer, and not some other answer? Watch what happens. The honest ones will tell you we don't fully know. We can make educated guesses. We can run interpretability experiments that illuminate corners of the system. We can point to attention patterns, to feature activations, to the statistical landscapes that the training process carved out. We can build tools that approximate explanations. But we cannot trace the path, not really, not completely. This is the black box problem in classical AI, and it is real, and it matters. Here is the technical core of it. A large language model, the kind of system that powers the most capable AI assistants today, contains billions of parameters, mathematical weights arranged in layers that transform input into output through a cascade of matrix multiplications. When you type a prompt and receive a response, what has happened is this: your words were converted to numbers, and those numbers pass through hundreds of layers of weighted operations, and at the end, a probability distribution over possible next tokens was computed, and from that distribution, a word was selected, then another, then another. At no point in that process did a switch flip that said, explain this simply. At no point did a subroutine run labeled be funny here, or use a metaphor now. Palo Alto Networks, in their analysis of large language model behavior, put it this way: when an LLM is asked to explain quantum physics to a child, there is no single simplify switch being activated. Instead, the tone, structure, and vocabulary emerge from thousands of interacting components adjusting to context. The behavior is real. The behavior is predictable. The behavior is useful. But the mechanism is distributed across a space so large and interconnected that the human eye cannot trace it. This is what scholars have called remediable incomprehensibility. The philosopher Frank Pasquale coined the term to describe the opacity of algorithmic systems, and the key word is remediable. In principle, given unlimited computational resources and time, you could trace every calculation in a classical neural network. You could, in theory, reconstruct the chain of causation from input to output. The opacity is not metaphysically guaranteed. It is practically overwhelming. This is why an entire field exists to address it. Explainable AI x AI is now a substantial academic discipline, with its own journals, conferences, and funding streams. researchers have developed tools like SHAP values, which assign important scores to input features, LIME, which builds local approximations of complex models, attention visualization, which shows which parts of an input the model focuses on at each step. These tools are real, they are useful. They have helped us understand things about neural networks that we did not understand before. But here is what they cannot do. They cannot give you a complete, faithful, end-to-end explanation of why a model produced a specific output. They give you approximations, local descriptions, partial pictures. The journal paper in MDPI's AI journal that surveyed the field in late 2025 was honest about this. Traditional models act as black boxes that limit trust and accountability. And while XAI has made progress, the gap between what we can explain and what the system actually does remains significant. The darkness of classical AI is real, but it is, in principle, negotiable. Which brings us to the second box. I want you to hold two numbers in your mind simultaneously. The first is the complexity of a classical neural network. A model like GPT-4 has roughly 1.8 trillion parameters. That is 1,800,000 numbers. The interactions between them, during a single forward pass, involve computations that no human could trace in real time. That is one reason for the black box. The second number is more abstract, but far more important. A quantum system with 100 qubits exists in a mathematical space with 2 to the power of 100 dimensions. That is approximately 10 to the power of 30 a 1 followed by 30 zeros. The total number of atoms in the observable universe is estimated at around 10 to the power of 80. So the mathematical space that a 100-qubit quantum system inhabits is larger than the number of atoms in the universe by a factor of 1 nonillion, a 1 with 30 zeros after it. This is not a description of computational power. This is a description of the territory in which quantum AI thinks. And here is the critical thing: no classical computer, no matter how powerful, no matter how large, can efficiently navigate that space. Not because we haven't built the right hardware yet, because the laws of quantum mechanics make efficient classical simulation of quantum systems impossible in the general case. The computational cost grows exponentially with the number of qubits. It is not a scaling challenge. It is a wall built by physics. Nature Communications published a rigorous review of this in December 2025, putting it plainly: AI, as a fundamentally classical paradigm, cannot efficiently simulate quantum systems in the general case due to exponential scaling constraints imposed by the laws of quantum mechanics. Classical simulation of quantum circuits suffers from exponential growth in computational cost and memory consumption. Read that carefully. AI, classical AI. The most capable AI systems we have built cannot efficiently simulate quantum systems. That is not a criticism of AI. It is a statement about the nature of quantum mechanics. Now put those two facts together and see what they imply. We are building AI systems that operate in quantum space. Those systems are learning, optimizing, finding patterns, generating outputs, all within a mathematical territory that no classical system can retrace. And crucially, this means that when a quantum AI produces an answer, there is no classical path we can walk backward along to understand how it got there. Not because we lack the tools, because the tools that would be needed do not and cannot exist in classical physics. This is a different category of black box, not a box we can't open because we haven't built the right key yet. A box that physics says cannot be opened by any classical means. Ever. I want to be precise about why this matters because I think the practical